Okay. Question number 1. A beer distributor claims that a new display featuring a life-size picture of a well-known athlete will increase product sales in supermarket by an average of, what do you understand by average? Anybody? What do you understand by an average?
The population.
Okay.
Is it?
What do you understand by average? The word average.
Or less.
Okay. The word average means mean, like mean.
Yeah.
Mean. That's a mean. Oh, okay. So this one is the population mean. So the population mean mu, we know that it is equal to what? To 50 already as a null hypothesis. Then they are saying that an athlete, okay, for a random sample of 20 supermarkets, what is this? This is a sample size, isn't it?
Yes, sir.
The sample size is 20. The average sales, what is this average? What is this average now? Hello, I want us to participate so that
The mean.
this is the mean from the from the sample. This is a sample mean. It's 41.3. And the standard deviation, the sample standard deviation. Now listen, the sample standard deviation is represented by this small s. The standard deviation is 12.2. The question is this one. Can you test at the 5% level of what? At 5% level, the null hypothesis is that is that the population mean sales increase at least 50 what? At least 50 what? 50 cases. Setting any assumptions you make. Now, here is something that you have to pay attention to. Looking at the question, the way how the question is asking. Can you test if the null hypothesis will be at least what? Will be at least 50 cases. Meaning you are testing that mean will be what? The population mean, which is mu. Mu will be greater than what? At least it means greater. You are testing that mu will be greater or equal to what? To 50. Are you following that?
Yes, sir.
Yeah, I want you to understand the question, then you answering is easy. So the question is that you test at the 5% level of significance that the null hypothesis that the population mean sales increase is at least 50. At least 50. The average is 50, but it is at least 50. What are you testing? So you are testing that the null hypothesis is greater than what? You are testing that the null hypothesis at least means greater or equal to what? To the mean. Yeah, so these words, you need to understand what they mean, just as I just guided. So what is our alpha? Very important.
Sir.
Ma?
But you're saying at least means greater or equal to, is it? Oh, but this sign here, isn't this less? Does this mean less or equal to?
This is greater. Have I forgotten? I don't know. I left school a long time. But this is greater, I think.
That's greater.
Anybody? This is greater. This is greater or equal to. Because less, I remember that teacher was saying what?
Oh, okay. All right. It's me who yeah, it's the right hand. Okay.
Yeah, she was saying left hand, right.
Okay.
I remember what she was saying those days. Yeah, it's greater. Okay, our alpha is what? What's our alpha?
0.05.
0.05. Now look at this one. This one, you need to assess how your data is what is distributed. Check that these people are saying that the mu is greater, which means your alternative hypothesis would what? Would be that it is less, right? You say that mu is less. You do the opposite. If mu is, you say mu is what? Is less or equal to what? To 50, meaning it's less than 50. That's your alternative HA, right? The alternative hypothesis is the opposite of the null hypothesis. I'm sure you've gotten that. So since this data now is distributed, like it's single-tailed, you have seen that it is single-tailed. It is greater, it falls on one side. Then it means you are not dividing your what? Your alpha. Did you get that? Yes, sir, we got that. Your alpha still remains that. So now, again, you need to make assessments. Are you using a t-statistics or a what? What is that? Or a z or z statistics? Hello.
We're using a Z.
Hello.
We're going
Which
to use
statistics are we using? All right.
a Z
People
test.
are saying a z test. Interesting. What about others?
We use a T.
Okay. Why do you say we use a T?
Because the sample size is less than 20, less than 30.
Okay. Yeah. So we use a what? A T statistics because the sample size is less than what? 30. So how do we calculate? We need the let's calculate first one. Let's do that one. We calculate first. Our T will be x bar minus mu over the standard deviation divided by the square root of what? Of n. Isn't it?
Yes.
Yeah. So what is our x bar? Our x bar is 41.3. Then what is our mu? Our mu is 50. Our standard deviation is what? 12.2. Then the sample size is 20. Anyone to give us what you get? At least 2 people to calculate. What is the T, the calculated T value? Hello. Two people can do the calculations, or 3, 4, 5, or everyone, actually. It's recommended. Hello.
135.28.
Like the final answer.
Yes.
135. That number sounds so big. Are we getting 135? Are we getting the same thing, all of us? This is 41.3 minus 50.
50
over
let's
4.2.
Oh, it's 41.3, yeah?
Yes. The number sounds so huge it cannot be found on the table.
I'm finding a negative. Is it possible?
Yeah, it's possible. It's
Oh, I
possible to find
found
a negative. Very much
negative
possible.
3.1. But let's confirm from others. But I found negative 3.189.
Negative at negative
3.1
3.189.
89.
Okay,
1
just that.
4.
Okay, just
Okay,
that.
let's confirm with others first.
I've also
What
found the
about?
same one.
Okay, anyone else?
It's the same.
Oh, okay. If it is the same, this is the calculated value, right? You know that now we need the one that you get from the table. I think this is now the repetition of the things. You should be able to get it plain now. So for this one, you need what? What do you need for the t-statistics? The degree of what? The degree of freedom. You need the degree of freedom that you find by n minus 1, comma, your alpha. And since this is a single tail, isn't it? We say this is a single tail. You don't divide your alpha. What is the sample size? 20. 20 minus who is this one? 1. It will be 19, 0.05, isn't it? Clear? So are we fine with this so that we go to the table? Okay. Assuming that the silence means that everyone is okay. We can go to the tables. Let me quickly go to the table. Where is it?
It's 1.729.
1.72.
1.729.
Oh. Okay. Let's compare them together.
Yeah, of course.
The t-statistics. Okay, it's here. At our degree of freedom is what? It's 99?
Yes, 19.
So you come on 19. Our 19 is here. 19, 0.05, right?
That's the normal standard distribution. Oh, okay. Shared.
This is a T. It's a T. Once you have the degree of freedom, you are dealing with the T.
No, you had shared the other one. I'd seen the other one. Sorry.
Well, did you get it? So this is the critical value, 1.729, right? 1.729. 1.729. Then anyway, let me just share the board since we are concluding. Okay. 148. Where is our exercise? Okay. We said that what is our critical value? Is 1.729, right?
Yes.
We are comparing the one that we calculated was what?
Negative 3.189.
Okay, so check. So since it's a negative, it means it will be on this other side where there are negatives, right? So it will be on this other side here where there are negatives. So your number is negative 3. It's on the what? On the rejection region, right? It will be somewhere here, isn't it? As you move from the 0 towards the left, the negative values are increasing. Did you get that? Your -3 will be somewhere here. So it will be in the rejection region. Therefore, you do what? You reject the now what? The now hypothesis. Which means there's it is not what? It is not true that what? That the chan these none can be the cases can be above 50.
50.
May the co-host stop recording class and